This is a key to a worksheet dealing with the section on graphing exponential functions. And number one, you're told that this point 3 to 16 is on the graph of the function 6 to the x. So we have this exponential function. So notice that this point's in there. So you can verify that that point is correct when x is 3, right? So 6 to the third power. So 6 raised to the third power, you see you do get 216. All right, so that point's on the graph of this function 6 to the x power. Now, in terms of translations, this point translates to what point on the graph of 6 to the x minus 20. All right, so if you look back at the function, the basic function here, 6 to the x, so remember that point here is on the graph of that function. So 3 to 16 lies in the first quadrant. So here's the point 3 to 16. Now we know that the graph looks like this. So we have the horizontal asymptote being the x-axis. And so when I graph this function here, 6 to the x minus 20, remember what that does in terms of translations. So this negative 20 out here, the subtracting 20, basically what it does is it shifts the point 3 to 16 down 20 units. So shifting it down 20. All right, so when we shift up or down, I want you to keep in mind what's happening to the x-coordinate, what's happening to the y-coordinate. So when we shift up and down, the x-coordinate stays the same. Every point when I shift up or down is still going to have the x-coordinate 3. The y-coordinate, though, is the one that changes when we do a vertical translation. So when we do a vertical translation, the y-coordinate changes. So we went from 216, and we're shifting that point down 20 units, so we're subtracting 20 from the y-coordinate. And so when I do that, I get the new point 3, 196. So 3 to 16, when we translate this down 20 units, is going to be the point 3, 196 on this function. So we're going to have the answer being 3, 196. All right, and you can verify this on this function. So check. So when x is 3, notice what we get. We get 6 raised to the third power, and then minus 20. And I want you to notice that I get 196 from a y value. All right, so we get 3, 196. Okay, now number 2, we have this. We have the point 3. 343 is on the graph of 7 to the x, and you can verify that as well. So when x is 3, 7 raised to the third power is 343. Okay, but remember where this one is. Let me go ahead and rewrite the function here. So g of x is equal to 7, that's a 7, 7 to the x plus 10. Now notice this is not a vertical translation like this was. This is a horizontal translation. And when we do a horizontal translation, you got to think counterintuitive of what you would think. Basically, when you do a horizontal translation, it's always a good idea to rewrite it as x subtract. And so x plus 10 really becomes x subtract a negative 10. And so this negative 10 means that I'm going to shift horizontally the point to the left, because see in parentheses it's negative, so to the left 10 units. Okay, so that's what that means. And so when I look at the point 343, which is also in the first quadrant, so this is 343. Remember, I'm shifting it to the left. I'm going to write it like this: left 10 units, right? And so basically, when you shift a point to the left or the right, notice that all those y coordinates are the same. It's the x coordinate that changes. And so this new point here, whatever that point is, and we're about to find it, that point is going to be 3 subtract 10, comma, because you're subtracting 10 only from the x coordinate. The y coordinate stays the same. And so 3 subtract 10 becomes a negative 7, so you get negative 7, 343. All right, so that's the answer to number 2. So negative 7, 343. So the y-coordinate, the y-coordinate stays the same. It's the x-coordinate that changes. So you have to recognize that for g of x, we had to take this point here and shift it to the left 10 units. All right, and then in number 4, we have two transformations occurring. All right, we have a horizontal and we have a vertical. So you're told that the point 481 is on the graph of the function 3 to the x. And you can verify that that's correct. 3 raised to the 4th power. So 3 raised to the 4th power equals 81. All right, so I'm going to go ahead and kind of do this. So here's number 3. So the point 481 is here, okay? And all right, so that's going to be on the graph of the function 3 to the x. Whatever the graph may look like, just sketching it very roughly, it'll look something like this, okay? But regardless, this point is on the graph of 3 y equals 3 to the x, right? Okay. Now, what I want to know is when we use translations, this point becomes what point on g of x, which equals 3 to the x minus 2 plus 4. All right, now always do a vertical translation last. So let's do the horizontal first. So basically, this x minus 2, this horizontal translation tells me that I've got to shift the point to the right 2 units. So I'm going to go to the right 2, okay? So when I go to the right 2, remember what happens when you go to the right or the left. When you go to the right or the left, the y-coordinate stays the same, is the x-coordinate that changes. So when I go to the right 2, I get the point 4 plus 2, comma, 81, which equals 6, comma, 81. All right, so that's my horizontal translation. But then I have to do a vertical translation, so that's plus 4. So meaning I'm going to take this point here that I just found, let me put a little dot there, that I just found, I'm going to shift it up 4 units. So I'm going up 4 units. But remember, when you go up and down, notice that the x-coordinate stays the same, it's the y-coordinate that changes. So now, for this point here, my x-coordinate stays the same, so it'll be 6, and then I'm going to add 4 to 81, so 81 plus 4. And so then my final answer is going to be 6, comma, 85. Okay? So 6, comma, 85. And you can verify that, by the way. So let me go ahead and show you. So we're going to get the point here, 6, comma, 85, right? And so to verify that, in place of x, you're going to substitute 6. So I get, so just watch. Let me do it here. So I get g of 6 is going to equal 3 to the 6 minus 2 plus 4. So wherever I see a variable x, I'm substituting 6. And so when I do that, I get 3 to the 4th power plus 4, right? And so 3 to the 4th plus 4 equals, my y value is 85. All right, so that's it. All right, so you get 6, comma, 85. All right, number 4. So number 4, you have the function, let me go ahead and write it over. It's f of x equal 4 to the x plus 7. All right, so it says this. To graph this function in terms of translations, you would take the parent function and shift it blank units to the blank. All right, so remember, this is a horizontal translation, right? So think of this as being 4 to the x minus a negative 7. So that negative 7 means I'm going to go to the left 7 units. So you're going to shift it 7 units to the left. That's the answer there. Number 5, so the function f of x equals 2 to the x is shifted 4 units down. Write a function for this translation. Well, remember, down is that vertical translation. So you know that should be 2 to the x and then subtract 4. Number 6, this time you're shifting it to the right, 3 to the x. So that's going to be 3 to the x. And now I'm going to write this minus, and then just kind of like we did this right here. So x minus, and then whatever my translation is. So it'll be x minus, let me go ahead and do this, g of x equal 3 to the x minus, now I'm shifting to the right, right? So that's a positive 5, but x minus a positive 5 means the same thing as just saying x minus 5. So that's the answer. Number 7. So number 7, f of x equals 4 to the x is shifted 7 units to the left and then 3 units up. So let's think about that horizontal first. So we're going to write it just like this. So b g of x will equal 4 to the x minus. So that's your horizontal. I'm shifting it 7 units to the left. So that means a minus 7, like this. And then the vertical translation is 3 units up, so that's a positive 3. Now let's go ahead and simplify this part here. X subtract a negative 7 means x plus 7 and then plus 3. So that's the answer. So it'll be 4 to the x plus 7 and then plus 3, just like that. All right, so in number 8, the final one, you have f of x equals 7 to the x plus 3, and indicate the following. What's the horizontal asymptote? Well, remember this number here on the outside of your exponential part is the horizontal asymptote. But remember, the horizontal asymptote, the graph of an exponential, never touches or crosses the horizontal asymptote. So basically, you're going to have something like this, just a rough sketch. So it's a horizontal asymptote is 3, like this. 7 to the x, 7 is greater than 1, so I know that I'm going to have an increasing function. So it looks something like this. All right, now remember the graph gets closer and closer to the horizontal asymptote without touching or crossing. So in terms of the horizontal asymptote, it will be this dotted line right here, so y equals 3. And remember, whenever you list a horizontal asymptote, the horizontal asymptote is a line, so you must name this line. So just don't put it 3. You got to say y equals 3. That's the equation of that line. That's the name of that line. The range, remember, is the set of y coordinates. So as I go from bottom up, notice that, remember what we said, the graph does not touch or cross the horizontal asymptote. So it gets closer and closer and closer to it without touching it. So it will be from 3 to infinity, the 3 being with parentheses. So 3 comma infinity. All right, so that was the key to this worksheet.